Oakley dokley, here we go, ladies and gentlemen. Now we are going to be graphing these bad boys, okay? And I'm just going to give you a system, like a sequence of steps that you have to do, and we'll go through a bunch of examples, and hopefully it'll clear up a few issues, okay? So first of all, the steps to graphing. Now, identify any vertical asymptotes. Those obviously occur when you have, these are your restrictions, right? So with these, what you're looking at is your restrictions. Okay, these are restrictions on x, right? So those are in your denominator. The second thing you want to do is identify any horizontal asymptotes. Now, there's a couple ways we did that, right? You could pick a large number if it's an easy function, or you divide by that highest degree in the denominator, okay? And divide every term by that highest degree in the denominator. We'll find your horizontal asymptote. Yeah, and that's basically it. The next thing is that you want to find any x and y intercepts. Now, you cannot forget that with your x-intercept, okay, it's y equals 0, and with your y-intercept, it's x equals 0. That's come up a lot, and it's never going away. Okay, it's always going to be that. And the last step that we're going to do is just find a table of values for some more points, okay? And it's basically simple as that. It could be a laborious process. It's a painstaking process at times, and it's sort of just a piecemeal thing, one step at a time. Okay, there's no quick fix here. There are so many different types of rational functions. Once you start throwing cubics and quadratics in there, it gets a little complicated. Okay, you're going to have possibly 2, maybe even 3 asymptotes. Where does it curve? How does it work? Okay, so let's give this a shot. Let's look at the first one here. 2 over x minus 1. So identify your vertical asymptote, first of all, as x equals 1, right? A horizontal asymptote, well, the bottom is larger than the top, so your horizontal asymptote here will be y is equal to 0. Okay? Now, any x and y intercepts, well, x-intercepts, okay? Y would be 0. You've already got it. Y equals 0 is your horizontal asymptote, so you don't have any. There's none there. How about your y-intercept? It's where x is equal to 0. And if x was 0, 2 over negative 2, 2 over negative 1 is negative 2. So let's use this information to plot up some of this stuff here, okay? So my vertical asymptote is at x equals 1, right down there. My horizontal asymptote is at x equals 0 right there. And I know it goes, my y-intercept is negative 2. So I've got a few things. Now we just have to plot some points. So let's make a table of values, right? Bang, bang, x and y. Now what we're going to want to do is we're going to go on either side. I already have 0. So how about we go negative 2, negative 1, get those two, and get these two, 2 and 3. Okay? So if x was negative 2, minus 2 minus 1 is negative 3, so that would be negative 2/3. Negative 1 would be negative 1, 2 would be 2, 3 would be 1. So at negative 2, it's 2/3. At negative 1, it's negative 1. So you can kind of get an idea here already. Bang! There you go. Now at 2, it's 2. And at 3, it's 1. You're getting an idea, hopefully here, that you go, wow. There you go. And you've graphed this function right here. This is y is equal to 2 over x minus 1. All right? Let's look at the next one. Now, in this case, what you're going to want to do is you're probably going to want to break this down into x plus 2 and then x minus 1. If you factor this thing out, you can see that you take the negative out, then it's x squared minus x minus 2. So if you wanted to go all the way here, you'd have x minus 2 and then x plus 1, and it's all negative here. Now, you can't cancel anything out there. You can't rearrange anything, so this kind of screws you up. But what you can see is that your vertical asymptotes are at x equals 2 and negative 1. Your horizontal asymptotes, since the degree is the same, right? How about we divide everything by x squared? So x squared over x squared plus x over x squared minus 2 over x squared. Now, 2 over x squared plus x over x squared minus x squared over x squared. The idea is that these all go away. You end up with 1 over negative 1. So you have negative 1 as being your horizontal asymptote. So we're looking at this one now. Okay, now I have a vertical asymptote at 2. I have a vertical asymptote at negative 1. I have a horizontal asymptote at negative 1. And you got a pretty good idea of what's going on already. Well, you got the asymptotes anyways. So let's look for the y-intercept. That's where x is 0. So 0, 0, that's going to be minus 2 over 2, which is negative 1. So you know it's going to wait a second. Y-intercept, your x is 0 minus 2 over 2. And negative 1. How can it be negative? Oh, wait a second. What am I doing? Okay. Well, let's just see what happens here. Where am I looking? X squared plus x. Yo, I guess, well, you know what? There's so many weird things with these things. Let's see what happens here. So, what about your X-intercepts, right? Your X-intercepts. This is an important point that I want you to get at y equals 0. If you're looking at this thing right here, if you're looking at x squared plus x minus 2 over 2 plus x minus x squared, if you want to find your X-intercepts where y is 0, if you want this whole thing to equal 0, all you need to do is look at your numerator. Okay, because if your numerator is 0, then your whole thing's 0, right? And we kind of found that up here. See that I went x plus 2 and x minus 1? So it means my x-intercepts are negative 2 and positive 1. So positive 1 and negative 2 are two values that we have here. What is the other thing going on here? So now what we got to do is find a table of values. So let's do a table of values and try some numbers on either side here. Okay, let's try negative 3 is one that we're going to want to try. How about we try positive 3 as well to see where my graph is. I think on this side I can see it's above, right? What's happening over here? We're going to have to look at that one. So at negative 3, right, that's going to be 9 minus 3 minus 2, which is 5. So at negative 3, we're going to have, that doesn't make sense. Oh, 5 on the top, duh. So it's 5 over 2 minus 3 minus 9, which is negative 10. So it's negative 1/2. That makes more sense. There you go. So you can see that we have that part of the graph there. This is coming down like this. What's going on here? Can we actually cross here? Well, you know what? In a weird sense, sometimes we can cross an asymptote. The asymptote exists on the outside. It exists on the inside. If you want to actually find out what's happening in here, you can plug in negative 1/2 as well. We haven't finished with 3 yet, though. That becomes 9 plus 3 minus 2, which is 10. And that's 2 plus 3 minus 9, which is negative 5. So that becomes negative 2. So when you're at 3, you're down at negative 2. So you can see that your graph is underneath here. And there we go. The inside part, folks, is a little bit tricky. And in this case, I'm just going to tell you that it's right here. This is where your graphing calculator is probably a pretty good thing to be using. A pretty good tool to try and figure out if you've got the right idea going on. Anyways, let's look at another one here. This gets a little more complicated. Oh, this one's actually quite easy. So you can see right away that your vertical asymptote is at x equals 1. So there's my vertical asymptote. Okay, these are the same degree. If you wanted to simply divide everything by x, right, then you'd see you end up with 2 over 1 minus 1 over x, and the idea is that x, 1 over x, right, as x approaches infinity, is essentially 0. So you get a horizontal asymptote at 2. So my horizontal asymptote is at y equals 2. So I have a horizontal asymptote right there. And now the idea is to graph it, right? Do you have any y-intercepts? So here we go, y-intercept, right? X equals 0. So that's going to be 0. And it just so happens that it is one of our x-intercepts too. And if you wanted to find the x-intercept, right, that's where y is equal to 0. So again, we have the situation where you go 0 is equal to 2x over x minus 1. You want to simply look at the numerator. The mathematics here is that to rationalize this, you get rid of the denominator by multiplying it by itself. Boom, that cancels, gives you 2x. Boom, that's just 0. You can see that x is equal to 0, y is equal to 0. They're both equal to 0, so that is my x and y intercept, okay? So it's 0 and 0 there. Now the next step would be to find some more points, right? So what we're going to do is we're going to plug some values in and use the equation, use the fact that you have an asymptote here to figure something out, okay? Use the numbers just like, so you have 0. How about -2, -1? You can't do 1, so how about 2 and 3, just to give us an idea, right? So -2 is going to be -4 over -2 minus 3. So at -2, it's going to be 4/3, which is 1 1/3, so right about there. At -1, it's going to be -2 over -2, which is 1. There you go. So you can get an idea, it's going down like this. On the other side, if we do 2, that's going to be 4 over 1, so at 2 it's 4. 3 is going to be 6 over 2, so it's 3. 3 and 3, and you get an idea. Here we go. There is the other side of that graph. Okay. Wow, I have a few more in here. I'll give those a shot. I might have to stop here pretty quick. But let's just keep going here. So notice that they are the same. So by definition, my horizontal asymptote is equal to y equals 0. What do you have a vertical asymptote? Is there anything that makes this denominator 0? There is none. Okay, so all we have is a horizontal asymptote at y equals 0. So boom, let's just do this. Okay, let's look at some x-intercepts. Let's do y-intercepts first. That's going to be x is 0, so it's going to be 0. Anyways, you know what? I'm going to have to cut this short here. We've got some stuff. Well, no, we should be able to do this. Let me just finish this off. Sorry, my horizontal asymptote isn't 0. Okay, my apologies with that. That's wrong. Let's just divide everything here by 2, by x squared. Sorry, so 2x squared over x squared, right? Over x squared over x squared plus 1 over x squared. So that's going to give me 2 over 1. So my horizontal asymptote is actually 2. Okay, because that cancels, gives you 2. That cancels, gives you 1, plus 1 over x squared. This goes to 0, so it's 2. Bam, 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 makes so much more sense. Now my y-intercept, absolutely, my y-intercept is 0, okay? Because if x is 0, boom, your y-intercept would be 0. So 0, it crosses here. Now, what happens, I guess that's my x-intercept too. Do you have any other x-intercepts? You'd have to make this 0. The only thing that would give you 0 is 0, right? So we got to figure out now what's happening on either side. So let's make a table of values. Let's find out what happens at -2, -1, 1, and 2. So at -2, that's going to be 4, that's going to be 8 over 5, which is 1 and 3/5. So -1, 1 and just over a half, right? Now, sorry, that's at 2, my apologies. What happens at 1, -1, right? That's going to be 2 over 2, which is 1. What happens at 1, same thing. At 2, you end up with 8/5 again. So you don't really have much choice. It's got to come down and go like this. You don't really have a lot of choice. Artistic, creative license is what's necessary here. You have to be somewhat creative. These are never points either. Okay, there's got to be curves because it's kind of a quadratic, so you know there's got to be a curve involved. Funky functions. I totally got you. Funky functions indeed. So these are a little bit different in the sense, let's break this down. So this would be x plus 2, this will be x minus 2, last one I'm going to do, okay? And then this is x minus 2, and this is x plus 1. Now, you can see that we can cancel something out here, and it ends up being x plus 2 over x plus 1. So what we're graphing is this essentially, but you can't forget that you have some discontinuities. Here, you still have a vertical asymptote. It's at x equals -1. So we put -1 all the way down, okay? Since these are the same, if you plugged in large numbers or did the division by the largest thing here, so x over x plus 2 over x, x over x plus 1 over x, those go away, you get 1 over 1. So you have a horizontal asymptote at y equals 1, which ends up being right here like this. Okay, now what we're looking for are x and y intercepts. Okay, x and y intercepts. Don't forget though, we canceled something out here, so you have a whole, okay, at x is equal to 2. And then what last thing we do is a table of values, boom, boom. 1 sec! Let's try 0, let's try 1, let's try 2, let's try -2, and let's try -3. Let's fill some numbers in here. So, if I put 0, 1 sec, please! It's going to be -4 over -2, which is 2. So at 0, you're up at 2. Okay? I've run out of time here, folks. I got to go answer the door. We'll do some more of these in class. Please give them a shot. Remember, just these things over and over and over, right? X and Y intercepts, asymptotes, you should be good.